We're solving this circular motion question, page 133, number 4. This is take 2. If you saw my first one, there was a little typo in it as I wrote it. So we're going to redo this one. It's the same question though. We've got this bird of this mass pulling out of a dive, the bottom of which can be considered a circular arc. So we're going to picture this circular arc here. The bird is at the bottom of that. The entire flight path doesn't need to be a circle, it's just this part of it is a circle, so the bottom of which can be considered a circular arc. As it goes around in a circle like this, the bird has this constant speed, so we know that's v, and we also know over here the radius, so that's r. So we know v and we know r. We know when we solve this thing, our circular motion, let's say fc is mv squared over r. That's our circular motion equation. This thing really, this fc is really sum of f, and this thing here, mv squared over r, is really a, so this is ma. Okay, so mass is mass, acceleration is v squared over r, not r squared, which is what I had in the last one. Sum of f is fc. This sum of f, this net force that's here, is the same idea as centripetal force in that it's not a force that's going to appear on our free body diagram. So let's go over here and make a free body diagram and see what forces act on this thing. There's for sure the force of gravity acting down, and there is some force that acts, because of the bird's wings, there's some force that kind of creates lift. It doesn't really matter what it is for now, but we've got some kind of a lift force. I need, in order for this to be circular motion, I need there to be an acceleration up towards the center of the circle. What that means is this lift force has to be bigger than that force of gravity. That's just something that we can keep in mind as we do this. I'm going to say up towards the center of the circle is my positive direction. I always like to choose towards the center of the circle as positive because remember, this acceleration here, this thing is a vector. Net force is a vector, that acceleration is a vector, but right here we're not going to get a vector out of this. Remember, v is just speed, r is just radius. When I sub those numbers in, I'll never get a negative out of it. If I'm going to choose down as positive, then I have to just put a negative sign in here. I like to avoid that, so generally speaking, I'm always going to choose up towards the center of the circle as my positive direction. That way I don't have to worry about getting a negative here. I can just put my numbers in and the negative will work out. This fc then, like sum of f, it means add those forces together. So I'm going to have a lift force going upwards, plus I'm going to have force of gravity. That force of gravity is down, so I'm going to put a negative sign in there, and that's equal to mv squared over r. Some people don't like to put the negative sign in here. They like to leave it as fg is mg, and then little g will give them their negative sign. That's fine, as long as you get a negative sign somewhere in this one. If I bring this thing over to the other side, I could say the lift force is mv squared over r plus fg. And keep in mind, fg is just mass times 9.8. So this lift force is mv squared over r plus mg. Now we can go ahead and start subbing numbers in. So the mass we know is 0.211. Speed 21.7, that's squared. Radius 25.6, not squared. Mass out here, g is 9.8. Remember, I already put the negative sign in here, so I am not going to put a negative sign here. If you didn't put the negative sign there, you would bring it over here, you'd have a negative, we'd have a negative, but we'd also have a negative here. Those two negatives would cancel to give us positive. Okay, so either way, that's fine. That's the same thing. We work these numbers out, and we can add that together, and we can get this lift force, 5.95 newtons. That is up. This thing is a vector. And that's it.